Hello everyone. Today let's go through the numbers in Python. In the world of programming, Python stands out as a versatile and powerful language, and numbers play a crucial role in various aspects of Python programming. Whether you are dealing with simple arithmetic operations or complex mathematical computations, understanding how Python handles numbers is essential. So let's get started.
Welcome to Data Science Cheat Sheets channel, transforming lines into limitless creations.
Python supports various types of numbers, including integers, floats, complex numbers. One notable feature of Python is its dynamic typing, which means you don't need to explicitly declare the data type of a variable. Python interpreter dynamically assigns the type based on the value assigned to the variable. This flexibility makes it easier to work with numbers without worrying about type declarations. Underscores in numbers. When you are writing long numbers, you can group digits using underscores to make large numbers more readable. When you print a number that was defined using underscore, Python print only the digits.
Integers. Integers in Python are whole numbers without any decimal points. They can be positive or negative. Python allows unlimited precision for integers, meaning you can work with extremely large or small integer values without worrying about overflow or underflow.
Floating point number. Floating point numbers, or floats, represent real numbers and include decimal points. While they provide a way to work with non-integer values, it's important to be aware of potential precision issues due to the limitations of floating point arithmetic.
Complex numbers. Complex numbers have both a real part and an imaginary part, expressed as shown here, real plus imaginary. The imaginary part is represented by appending letter J to the value. Complex numbers are useful in various mathematical and engineering applications. Numeric operations. Python supports a wide range of numeric operations, including basic arithmetic such as addition and subtraction, multiplication and division, as well as exponentiation, integer division, and modulus, remainder, operations. Let's assign two values, a equals 10 and b equals 3. Addition adds a to b equals 13 in our example. Subtraction subtracts b from a equals 7. Multiplication multiplies a by b equals 30. Division divides a by b equals 3.33. The result is floating point number. But if the goal is to get integer, then the operation shall be done with 2 backslashes. The result will be integer 3. Exponentiation raises a to the power of b equals 1000. Remainder divides b by a and returns remainder. In our case, it is 1.
Type conversion. Python provides functions for converting between different numeric types. This is useful when you need to convert float into integer or vice versa.
Math library. The build in Math library in Python offers additional mathematical functions and constants. It includes operations like square root, logarithm, trigonometric functions, and constants such as pi. Built-in function. Python provides built-in functions for common numerical tasks. The abs function returns the absolute value of a number, while round function rounds off a floating point number. The max and min functions find the maximum and minimum values in a collection.
Numbers are used quite often in programming to keep score in games, represent data in visualization, store information in web applications, and so on. Understanding the nuances of numeric types, their operations, and potential precision considerations is essential for writing accurate and efficient numerical code in Python. Python's versatility in handling numbers makes it a powerful language for scientific computing, data analysis, and various other applications involving numeric data. Thanks for watching. All the code lines featured in this video are available in the Jupyter Notebook in the description. Please feel free to share this video, subscribe to our channel, and leave your thoughts in comments section down below. See you next time.